Okay, in this Jupyter notebook, we have three separate food printing structures. Just to give a quick preview on how the twisted triangle works, we have a set of functions, and then we have a set of parameters that we can place into the stack triangles function. By adjusting these parameters, we can change the print speed, the amount of extrusion, the extruder number, the starting point, and all sorts of other stuff. Just a quick demo. We want to print, let's say, 15 layers of triangles and have a rotation increment of 5 degrees. Okay, and we are given this G code. We can take this G code and put it into our G code simulator to verify that the G code is correct. And so here we can see what our G code outputs. This is the top view. It outputs triangles that are decreasing in size and rotating at 5-degree increments at each layer. This is our spire graph. And here we can see two sets of hexagons. And the reason why they're offset is because we have two different extruders that are separated by a 20 millimeter distance. Now to quickly jump into how the twisted triangles work. After we import our functions, we have an initialize, which calls the homing sequence, as well as sets the center of the printing bed so that we can print our triangles right in the middle of the printing bed. And then we have a function called generate triangles G code that takes in parameters of the center coordinates, the side length, the angle of rotation, the Z height, the extrusion multiplier, which means if we want to extrude less material over time, we can change the multiplier, same with the speed and the extruder number. This will then draw a triangle at a specified location. And then the stack triangles function will draw multiple triangles at an increasing Z height while slightly changing the angle of each triangle as well as changing the size slightly so that they get smaller towards the top. For the spire graph, we have the initialize function again, and then we just have another function that pretty much gives the path of the spire graph in G code. And then the hexagon layers, we have an initialize function. We have a function that fills a hexagon. The way we fill a hexagon is by drawing smaller hexagons inside of the outer one. The fill hexagon function is called upon each layer within the draw hexagon main function. In the draw hexagon main function, we can specify the center coordinate, the initial Z coordinate, the edge length, the step between each layer, the number of layers, the speed at which we print, the amount of material we extrude, and if we want to fill it or not. And that's pretty much how this works. And then messing around with the parameters, we can change the height, the spacing, the distance, a bunch of stuff. And this is what we use to then fine tune our print. We would then print something, analyze it, change these parameters, and then try again.
We peel our potatoes, cut them up, get them in boiling water that has salt in it. Once it comes to a boil, we're going to strain out the water, put it through a strainer to get it really soft, get all the lumps out of it. Then we're going to mash them up, put in the butter, put in heavy cream, mix it up into both the regular mashed potatoes and the sweet potatoes. Then use an emulsion blender to get it really, really thin. For the beans, we use a can of beans, poured it out, added extra water and pork fat. Once it came to a boil, we then emulsioned the blender as well to have a smooth, thin consistency out of the syringe.
Some lessons learned relating to food printing are for cooking, make sure you add a fat or a butter and use a blender to get the right consistency. You want good viscosity and to avoid chunks in your material. For putting the material into the syringe, try and avoid having bubbles at all costs as they ruin the amount of material that comes out. When you first begin to start printing, make sure you add a bit of a delay into your code so that pressure builds up in the syringe and that it comes out evenly right as it touches the paper. I would also be wary of the saran wrap. Make sure that there aren't any bumps in it and that it's as flat as possible. If there are bumps, then it will be really hard to stack the layers on top of each other. In addition, be wary of the offset between the two nozzles if you're using both of the extruders, as this can mess up the positioning of your shape. So just double check it using the G code and make sure that it makes sense that they will overlap with each other.